Hi, thanks for joining this presentation. I'm Alex and I welcome you to my Git with Visual Studio Code crash course. What can you expect from this course? We will briefly see how you can install Git for different operating systems. We will touch some basic commands, but most importantly, you will see how you can handle Git inside your favorite IDE, Visual Studio Code. We will touch some basic Git commands like init, commit, branch, push, pull, but we will also touch some more advanced topics like handling commit conflicts and merging branches. And we will do all of this inside your favorite IDE, Visual Studio Code. This course is designed to give you exactly what you need quickly because your time is important. So, of course, if this is the case, don't expect that after this course you will know everything about Git, but expect to be able to track your coding work nicely directly in your IDE. So this being said, if you like this presentation, please check the course curriculum, and if you like them, let's go in class. In this lecture, we will install Git. For this, I will go to my browser and search for Git install. I will open this website, gitscm.com. And here I have different options for different operating systems. I will go for the one on Windows, and this will lead me to a download page. I will download my executable and open it. And from now, just follow the steps. And with this, I can install it, and it will install. When this installation is finished, all I need to do to check if everything is okay, I will go to my command prompt and type git --version. And we should see a version, which means that we should have successfully installed Git on Windows. Let's switch to Linux. Of course, all we need to do here is make a sudo apt install git, and that's it. After this is finished, I need to do the same check for the version, so I'll say git --version. Again, I get the Git version, so it means that it is successfully installed, and the same can be said for installing it on a Mac. Instead of downloading the package for Windows, you can download the package for a Mac and install it using the installer. In this lecture, we will learn some basic Git commands, and this will be an atypical lecture because we won't use any VS Code features, but in order to understand what's happening behind the scenes, you need to know a little about some Git commands. Let's get started. I will create a new folder in which we will practice some Git. So I will call it git _practice, and I will open a terminal inside it. And the first command that we will use is git status, and this will show us what is the status of our source control inside this folder. Okay, we receive a message which says that this is not a Git repository. This is okay because this is not a Git repository. So let's make this a Git repository with the command git init. This will make our folder a Git repository. And now if we inspect our folder, you will see that it will create a hidden folder called .git, and this will contain all the information about Git regarding this folder. Going back, Now if we go to again git status, we will see that we have a branch master. We don't have any commit. Let's create a file in our folder, a simple plain text file. So I say initial. I will put a simple text here, save it, and now we have one initial file here. Let's add this to source control. For this I will select the command git add and with a dot, which means that it will add all the new files which it will find in our folder. If I now select git status, it will say that we have a new file which is ready to be committed, and let's commit this with the command git commit -m, which stands for message, and we will pass here a string containing a message which explains what we are doing in this commit. So I will call it first commit. Alright, now if we do git status again it says nothing to commit, and now we want to push everything to a remote repository, and for this we do it with the command git push. But of course we get a fatal because it says no configured push destination, and for this we need a repository, a remote repository to work with Git, and in this case we talk about GitHub. This is GitHub. It's a remote repository which we will use for this project. It is free, it works very well, and in the next lecture we will explore its functionality. In this lecture we will learn some basic Git commands, and this will be an atypical lecture because we won't use any VS Code features, but in order to understand what's happening behind the scenes, you need to know a little about some Git commands. Let's get started. I will create a new folder in which we will practice some Git. So I will call it git underscore practice, and I will open a terminal inside it. And the first command that we will use is git status, and this will show us what is the status of our source control inside this folder. Okay, we receive a message which says that this is not a Git repository. This is okay because this is not a Git repository. So let's make this a Git repository with the command git init. This will make our folder a Git repository. And now if we inspect our folder, you will see that it will create a hidden folder called .git, and this will contain all the information about Git regarding this folder. Going back, now if we go to again git status, we will see that we have a branch master. We don't have any commit. Let's create a file in our folder, a simple plain text file. So I say initial. I will put a simple text here, save it, and now we have one initial file here. Let's add this to source control. For this I will select the command git add and with a dot, which means that it will add all the new files which it will find in our folder. If I now select git status, it will say that we have a new file which is ready to be committed. And let's commit this with the command git commit -m, which stands for message, and we will pass here a string containing a message which explains what we are doing in this commit. So I will call it first commit. Alright, now if we do git status again it says nothing to commit. And now we want to push everything to a remote repository. And for this we do it with the command git push. But of course we get a fatal because it says no configured push destination. And for this we need a repository, a remote repository to work with Git. And in this case we talk about GitHub. This is GitHub. It's a remote repository which we will use for this project. It is free, it works very well, and in the next lecture we will explore its functionality. In this lecture we will explore and use the GitHub repository. For this I am at github.com. Here you have the option to sign in or sign up. If you don't have an account, you can simply sign up. You can create a username, an email address and a password. I will sign in with my credentials. For this let's take where we ended in the previous lecture and create a remote for our Git practice project. And for this we need to initialize a new repository. So I will go to our repositories view here, and here I can select new, and it is important to give it the same name as you gave to this folder. So I will call our new repository Git practice. It will be a public. If you want a private repository, you need to pay. No problem, public is also fine. I will create this repository, and now I have information about it. Very important is this URL. This is the URL of our repository. I will copy it with this button and go back to our terminal inside our Git practice project. Here I will call the command git remote add origin and our URL from our repository. And now we can push finally. So I will say git push origin master. For this I need to provide my credentials. Alright, and now if I refresh this page, you will see that we have our initial tag, initial file with our commit message, and I can even open it and see its contents. Let's explore a little the GitHub interface at this moment. We have here our username and now the name of our remote repository. And as you can see, this is code, issues, pull requests. Let's explore a bigger repository, like for example the AWS SDK, the Amazon Web Services SDK. And here we can find the repository for AWS SDK for JavaScript. And here, as you can see, we see all the code because this is public. Here we can see the commits, the branches. Here we can see issues. There are even bugs or feature requests or problems regarding this project. And one more important Git command before finishing this lecture is the clone command. And for this I will select this button here, clone or download, to get the URL of this project, the Aves SDK. I will copy it and go back to our File Explorer. I will open a new terminal here and I will use the command git clone. And this will take this project from GitHub directly to my computer. It was a big project, but it's finished. Now I can simply change the directory to this Aves SDK, and I can open it directly in VS Code with the command code space dot. And here we can explore everything about this repository right from GitHub directly into VS Code. Now that we know a thing or two about Git and GitHub, we can start using them with VS Code. In this lecture we will install the one tool we need to develop TypeScript code, and we will need a code editor. The best choice for this is Visual Studio Code. Is the official code editor recommended for TypeScript. Also other Visual Studios are recommended, and also other IDEs can be used for TypeScript, but I see no reason than other to use Visual Studio Code. So let's go to its official website, and all we need to do for Windows and for Mac is to download the installation file. I will save it and execute it and just follow the steps. And the most important requirement here is to add two paths. This is an important requirement. Make sure you check this right here. The installation is finished. We can open this editor, but now let's see how we can do the same thing on Linux. And this time we will do some similar command. I will say sudo snap install code and -- classic. Provide the password. This will be much faster than IntelliJ. Alright, it finished. Let's check it. I can just say here code. It already installed the command and VS Code is starting. That's great. I was able to install VS Code so easy. Let's start to use Git inside VS Code. For this we will need any project that we worked until now. I will work on the backend project. It will be available as a resource for this lecture. You can use any project you want. I will open a terminal here and launch VS Code here. And for this I will close our files. It doesn't really matter. I will go to the source control tab. Here notice it says no source control providers registered. For this I will press the plus, but before doing this, let's check what is happening here in our terminal, the output view and the Git view. And as you can see, it already checked for if there are any source control providers, and it said it received a fatal, not a Git repository. Let's clear this out and select the plus sign. Of course, we want to initialize Git in this project. And as you can see, it will call a git init command. That means that it initialized Git in our project and it added the Git hidden folders. Also, as you can see, it prepared our changes to be committed. All of them now have an U here, which stands for untracked. We can add one by one and prepare them for being committed, or I can just select the changes, press the plus, and I will stage all the changes. Then I will just add a commit message. Of course, this is the initial commit, so I'll say initial commit. and press commit, this button here. This will commit. Now if I want to add our files to a remote repository, we usually do this with the push command. Of course we will get an error because it says your repositories has no remotes configured to push to. So let's configure a remote, and for this we need a remote. I will configure it inside GitHub, and I will create a simple repository with the name of our project, which is backend. So I'll go to my GitHub page. To my repositories, I will create a new one, and I will give it the exact name, and I will call it backend. Alright, it's okay. I will create this repository. And what it's important for us at this point is the URL of our repository. I will copy it with this button here, and I will call the command palette and call the command git add remote. We need a remote name, and usually the remote name is called origin. I'll press enter, and a remote URL, which in our case is the URL of the repository we just created. Press enter. Okay, it linked our remote repository to our local repository. Now we can push. And for the initial push, it will say that the branch master has no upstream branch. We will create this branch, we will publish it. And now we need to provide our credentials. So I will provide my GitHub credentials, the username and the password. Alright, and it pushed it. Let's check it on our repository, and if I refresh the page, this is great. I see my changes right here. This is great. We initialized Git inside VS Code. We will see what we can do with VS Code in the next lectures. So we have our project under source control from Git. Now if I go to my file explorer and start modifying files, as soon as I modify them, they will appear in our Git view. For example, if I just add a comment in our constructor, I have this comment here. Now my file will appear as changed here. Let's modify another file. Let's now modify the version inside our package.json, and of course our file now again will appear as modified. And as soon as I click it inside the Git view, the source control view, it will open it in a diff view, which means that it will show me on the left its old version, and on the right the new version with my modification. The same for my other file. I can again, of course, very simple. I can just write here, I will say update version. A very good practice is to keep your commits as small as possible, which means that you don't start to change all the files, change all your methods, all your dependencies, and then commit. It is usually a very good practice to make as small as possible commits. I will go to our source control, I will stage my changes, and I will commit them. Again, if I am making some changes which I don't like, and I don't want to lose time and to revert everything, I can go back to my source control view, and instead of staging it for commit, I can discard my changes. And this will fix my file, and it will be just like before when everything was okay. But there's one important problem with my project currently. I don't have our node modules. And for this I will go to my terminal and call npm install. This added the node modules folder to my project, and this folder is a massive, huge folder. And now if I go to my source control, I can click the refresh button if I don't see any changes. This sometimes doesn't work. And if I click the refresh in this moment, it will give me a big warning, and it will say that my current repository has too many active changes. And it will ask me to add my node modules to gitignore, which is very important. Of course, the first thing you need to do after you install your node modules is to make sure that they are ignored by Git. Otherwise, Git will work very hard. This command will create a simple file here. Every repository needs this file, the gitignore file, and it will add our node modules folder to it. And notice that this new folder here doesn't appear as modified in source control because it is ignored. I can just also commit this change, add git ignore, stage it, commit it, and push it, and provide my credentials. Let's see if everything is here. Yes, now I have the gitignore file. In the next lecture, we will work with branches. In this lecture, we will work with branches, and I'm currently in my repository view from GitHub, and here I have the option to create a new branch. Now I'm on the branch master, and I can create a new branch like this. And branches are very useful when you want to extend your functionality and work on your own outside of your team or of your colleagues. And also they are very useful to isolate parts of your code, features, bug fixes, or other important functionality. Let's give it a name to our new branch, and I will call it feature because it's a feature branch, and it will say some feature. I will create this branch, and notice it says create branch from master, which means that it will take the current state of our master branch and create a new branch with this name. Now we have it, and now we can go back to VS Code. Notice that also we can see on which branch we are currently in. Right here on the status bar on the left, we are on the master branch. If I press it, I get a pop-up with a list of branches, and notice that our feature branch is not here. That is because we didn't notify VS Code about our new branch. Let's do this, and I can call the synchronize button. But again, this will not work, so I will call a git pull. And notice that git pull knows that there is a new branch here. It knows its name, feature, some branches. And if I go again to our master view, now I can see it here. And if I click on it, we will change to this branch. This view is very useful and important. You always know on which branch you are working. It is frustrating when you work on a branch and you thought you were on another branch. Let's add some changes on this branch, and let's just change the README, and we say added a new useless feature, and we will increase the version in package.json, and let's add something let's add something in our data service class at the end. In the sort by position method, it doesn't really matter what you do now. I will just add again a comment, and I will call it feature comment, save this, and they appear in our changes view. I will commit them, I will stage them and commit them. You can give whatever comment you like. I will commit this, and notice as soon as I commit, the view here will change. This means that there are 0 incoming changes and we have our one incoming commit which is not pulled. Let's press this. And of course I need to provide my credentials. If you are on Windows, you don't have to do this anytime. Alright, our changes are here, and as you can see, they are in our sum feature. But let's say that we are working and our boss very fast comes at us and says that there is a critical bug in our project and we need to fix it. And let's switch our branch to the master branch. Let's say that we are not careful and we are working on the master branch to fix our bug. Notice that on this branch our comment is gone because it is not present on this branch, and let's say that the change was also here in the sort by position method. And here I will add fix critical problem. I will save this. I will also add a comment in the README and also increase the version in package.json. Notice that it is the same as we did for our feature. Notice that we are on the master branch and we figure out, hey, I can just commit directly to the master branch. I need first a separate branch in which the new change needs to be tested. And there is a very easy way we can create a new branch with our local changes. I will just call git checkout -b, and let's call this branch fix / critical fix. This will create this branch with our files here, and now I can safely commit these changes to our critical fix branch. I will add a commit message, commit this, and if I want to push it, it will say that the branch has no upstate branch. No problem, we can publish it. Now both our branches are also in our remote repository. Of course, we affected the same files, and if we want to merge the changes on the master branch, we will have conflicts, and we will see how to handle conflicts in the next lecture. In this lecture, we will handle conflicts between our commits. So we have our two branches, one with our critical fix and one with the feature. I'm in our repository. I will click this compare and pull request button. This will create a pull request, and it says able to merge. I will create this pull request. And now it says that this branch has no conflicts with the base branch, and I can merge this pull request. This will take the changes from our critical fix into our master branch. Now if we go back to our repository, it says that we have still this new branch, the feature one. Let's compare and pull request. Create this. I will create this pull request, and this says that can't automatically merge, and it says that this branch has conflicts that must be resolved. We will fix them. We can even do it from inside GitHub, but let's do it from VS Code. So let's change the branch to our feature branch. I will clear the terminal. And the way to fix conflicts on Git, the best way, is to take the current changes that exist on the master branch and integrate them into our feature branch, and then we will not have conflicts. For this, I will use some part of the terminal and some part in VS Code, and I will first start by checking out the master branch, because currently the master branch is modified and we need to notice VS Code about this. We will do a git pull, and this will take the changes we just did. Now we will check out our feature branch, and we need to provide the exact name. So this is called feature sum feature. Alright, and now we will say that, hey, I want to take the master branch and merge it first into my feature branch. So I will call git merge master. And here it says we will get the warnings here that we have conflicts, and these conflicts will also appear on our source control view. I can go to our readme file, and here appears with a C, which means that it stands for conflicts. And here we see that we have the incoming change and the current change. I can either accept both changes, accept the incoming one or the current one. This is the readme, so I can accept both changes. I will then stage this change, and this also the same problem is in our data service file, which we both modified. This time I can accept both changes, and this one looks okay. I can still have my feature comment and my fix critical command. I'll save this all. I will also stage this change. Yeah, this also needs to be done. VS Code sometimes has problem handling conflicts. That's why I tried to use the command line interface from Git. Now that we have our staged changes, I can also add a commit message here, and I will say merged master into some feature branch. Commit this, push it, and if we now go back to our GitHub view, we can see that we have a second commit which said merged master into some feature branch, and notice that we have no longer a commit conflict. We can also merge this pull request. And now if we go back to our repository, now on the master branch we have the changes from the critical fix branch and also from the feature branch, even if they were both on the same file. This is the way we can treat conflicts with VS Code and Git. In this lecture, we will install the Git Lens extension, which will help us a lot visualize the history of our project. So I will go to the extension view and search for Git Lens. And this is the extension. It is very powerful, and it has great reviews. I will install it. And as always with all the extensions in VS Code, when we install them, we are getting a welcome view which explains us how to use this extension. I will let you read this introduction file. Let's now explore this view. I will close this and go back to our view, and this extension added a new button in our status bar, the Git Lens view. Let's first view the repositories, and as you can see, we have the backend project, we have the current branch, we have the history of our current branch, And as you can see here, we see all our commits, all that happened with our commits. Let us open a file, and here, as you can see, we can see what happened in this commit and also what was changed along with this commit. This is a great view, the repositories view. Let's now switch to the file history view. And if we have a file opened, let's open a file. Let's say we open the data service. And if we go back to our GitLens extension, we can see all the commits that affected this file. We can see this commit, we can see this commit, and we can see what happened here. And as we select them, we see exactly what happened. We can even see the line history. And as you can see, if we have a selected line, it will tell us in which commit it was last edited. This is great. We can even, using this extension, compare branches. So if I will change all this, now we are in the compare view, and here we can compare even changes. I will select two branches. I will select the master branch and select the some feature branch, and we can see what is changed between them, what difference are between them, and what commits are between them. This is great. This helps us a lot deal with our code history. Another great feature of this extension is that if we open now a file, any file, and if we select a line, as you can see, it directly tells us in our editor who did what. In this case, it is myself, when, 3 hours ago, and we see the commit ID, initial commit. We see what happened and who did this file, any file. This is very useful when you want to know what happened and who did what in one particular file. Let me show you how a more complex project looks like when exploring it with GitLens. And for this, I will go to our Aves SDK JS that we checked out a few lectures ago. If you didn't do, you can check it out from GitHub. This can be done very easy if you go to Git and search for Aves SDK and search in all GitHub. We can find the Aves SDK in JavaScript in case you missed this explanation, and anywhere you can open a terminal and do git clone and your repository. This is the one. I already have it here, so I will not clone it again because it will give me a conflict. It will say I already have this project here, so I will open VS Code inside here. And now, if I'm in this view and go back to the GitLens view, you will see that the history view and the branches view and the compare view, it's much greater. You see, if I just select one file at just random one file, and I can select its file history, I can even see who did what and when. This is the beauty of working with GitHub and with public repositories with public source code. So if we navigate through GitHub and we look, for example, at the code from VS Code, and we scroll down in GitHub, we see that it has a very nice README file which looks great and explains us what this program does. The same for other projects on GitHub. There is their code, and at the end we have a README file which briefly and nicely explains what this project does. But for our project on GitHub, we see almost nothing. And for this, let's create in this lecture a nice README file for our backend project. For this we will use what is called a Markdown language, which is used to nicely format text documents. So let's go to our backend project in Visual Studio Code, and if we open our readme.md file, it will look like this. The nice feature about VS Code is that we can right click on a .md file and we can open its preview. Notice that we don't have this option for other file types, but for a readme we can also open its preview. And we can take the preview and put it on the side, make this smaller and edit the file, and in real time we can see how it will look. So let's start editing our readme file, and let's start with a description of our project. And here I will type the description, and notice these DS's here. They stand for headings, and so if we put one here, it will look big and nice here on the preview. We have our description of our project. We can add now a subtitle, and we do this with 2 DS's, and we will call this part setup. Here I will show how this can be set up. I will say that only that this project requires npm and node.js installed. Let's add another sub section for the build. I'll call it build project, and first of all we need to install TypeScript, and we can specify code with backticks, and notice how it will look if we put it like this. This is especially made for code. Let's add the other steps for installing npx and for running npm install. This is starting to take a nice shape. Now we need to launch the server, so we will add a new section. Again, we will add to, first of all, we will add the command that we need to run in order to launch our server, is this one, npx tsnode. And then we also need to check this. So I will say check localhost, and to make this a URL, I will put this in square brackets and add the URL. And as you can see, this will only add a link for our text here. And now let's add a new section with the services that our backend provides. And for this we can create a table. And tables are very easy to create in Markdown language. We only need the straight lines. And here we will say position and URL. And yeah, now VS Code doesn't know that we want a table, but if we add a new line here and if we add dashes, now it will know that we want a table. So I will only paste this table, and you will see how it looks. This is starting to look very nice. I will save all this, and now if we will only look at this preview, we will see that we have a nice description for our project. One important note: VS Code makes extensive use of Markdown language. If we go to the release notes, this is mostly wrote in Markdown. Also, if we go to settings, for example, and compare them, you will see that the settings menus look very similar to our README file. Is this a coincidence? I think not. Now, if we commit our change and go back to GitHub, I will refresh the page. Oh, we were on the some feature branch, no problem. I will create a pull request, merge it, and now our project looks like this also on GitHub, and someone else who takes a look at our project will have a much better understanding of what our backend does.